Chapter 1.5.7 DNS for Services and Pods. Kubernetes uses DNS to create records for both services and pods, allowing for consistent DNS names to be used instead of IP addresses. The information about pods and services is used to program DNS, and Kubelet configures pods DNS so that running containers can look up services by name. Services defined in the cluster are assigned DNS names, and a client pod's DNS search list includes the pod's namespace and the cluster's default domain by default. DNS queries in Kubernetes may return different results based on the namespace of the pod, making the query, and queries can be expanded using the pod/ec resolve.conf file. Pods in different namespaces can access services in other namespaces by specifying it in the DNS query. It is important to note that only services and pods are supported for DNS records, and any other layout or names that work are subject to change. For further information on DNS queries in Kubernetes, refer to the resolve.conf manual page or the Kubernetes DNS-based service discovery specification. AWA records are used for normal services with DNS pointing to the cluster IP of the service. Headless services, without a cluster IP, also have TRA records but point to the set of IPs of all selected pods. SRV records are created for named ports in normal or headless services, with the format port.portname.portprotocol.memi/svc.my-namespace.svc.cluster-domain.example. For regular services, this resolves to the port number and domain name, while for headless services, it resolves to multiple answers for each backing pod, containing the port number and pod domain name. This setup allows clients to consume the set of IPs or use round-robin selection. The text discusses how DNS resolution works in Kubernetes, specifically focusing on AAA records, pods hostname and subdomain fields, pods set hostname as FQDN field, pods DNS policy, and pods DNS config. In the context of DNS resolution, AAA records are created for pods exposed by a service, specifying the DNS resolution format. The pod's hostname is initially set to the pod's metadata name, but can be customized using the hostname and subdomain fields in the pod spec. The set hostname as FQDN field allows for the configuration of the pod's FQDN. DNS policies can be set on a per-pod basis to control DNS settings, with options such as default, cluster first with hostnet, and none. Pod's DNS config provides additional control over DNS settings, allowing users to specify name servers, search domains, and options for hostname lookup. A detailed example is provided for creating a pod with custom DNS settings. Overall, the text emphasizes the importance of understanding and configuring DNS resolution in Kubernetes for efficient networking and communication between pods and services. DNS search domain list limits. Kubernetes version 1.28 has a limit on the DNS config for the search domain list. The limit is set at 32, or a total length of 2048 for all search domains in the node's resolver configuration file, pods DNS config, and merged DNS config. Some container runtimes, like Containerd v1.5.5 or earlier, and CRIO v1.21 or earlier, may have restrictions on the number of DNS search domains, causing pods to get stuck in the pending state. DNS resolution on Windows nodes. Cluster first with hostnet is not supported for pods running on Windows nodes due to the way Windows handles DNS resolution. Windows treats names with a dot as fully qualified domain names, FQDN, and skips FQDN resolution. On Windows, DNS resolvers have slight differences in behavior, so using the Resolve DNS Name PowerShell cmdlet is recommended for name query resolutions. Windows allows only DNS suffix, which is the suffix associated with the pod's namespace. Windows pods can resolve FQDNs, services, or network names using this single suffix. Partially qualified names cannot be resolved within a Windows pod.